Okay, so we're gonna do a continuation, and this is how to solve part B. But before that, very quickly, so now we solve for IAN, and now a quick trick to find out IBN, ICN is we're just gonna, the magnitude is always gonna be the same. So 0.895, cool, 0.895, cool. What's left? The degree. And how do we solve the degree? Very simply, the formula for this was V over R. So we just look at the degrees over here, right? And if it says 30 degrees, and we just do a comparison with the final answer and what we had initially. So the change in this is 30 minus 17.2, which is 12.8. And if you subtract 12.8 from 30, you're gonna get 17.2. So 30 minus 12.8, you're gonna get 17.2. So the same concept for IBN, we're gonna use VBN divided by RR, and to get our angle, we look at the angle of VBN, which we said over here is 150, VBN 150, and we're just gonna subtract 12.8. 150 subtract 12.8. Very simply, what is that? 150 minus 12, which is like 137.8. Cool. Let me check that quickly. 141. Yeah, I'm so shit at math sometimes. Yeah, 12 point. Yeah. So 137.2. Cool. Same concept here. We look at our angle here, which is minus 90 minus 12.8. Cool. Which is negative 102.8. Now we just got IBN, ICN. Cool. Now we can move on to part B. Amazing. So now part B is asking us to solve the voltage across ZL. And how do we do that? We just use our formula. Voltage is equal to I times R. Voltage is equal to I times R. We already found all of our I's. So it's going to be IAN times our resistance, and the voltage across ZL. And IAN, let's just go over here quickly, 0.895. 0.895. Don't forget the angle, which is 17.2. 17.2 multiplied by ZL, which is, what the hell is ZL? Look at it, we said our ZL is 7. It's already given, so just look in the question. You don't even have to think about it. So right over here, it's 7 plus 14i. 14i. Do some quick maths, and then you're gonna solve this. Just multiply in your calculator, and you're gonna get. Let's try it out. Put my calculator. Complex. Mode. And 0.3, 2, cool. Alright, so we're just gonna plug it in. 0.895. 0.895. Shift 17.2 multiplied by 7 plus 14. What was it? Shift. Alright, yeah, this looks good. Okay. So this is our answer. Our voltage across ZL is going to be equal to 14 angle 80. Cool. And now we just do the same thing. Let's say VA. You just do the same thing for VB and VC. Cool. Alright, so that's gonna be our voltage across ZL. So now we're going to move on to question C. Question C says that we're going to compute the current through each voltage source. How do we do that? We just go over here. We look at our formula. There's a formula. The current through each voltage source, the formula for this is equal to IA so I is equal to IAN divided by root 3 multiplied by 30. So now you have to understand one thing. First, we solved if it was a negative sequence or a positive sequence, and in this case it's a negative sequence. Therefore, we're gonna make this a minus. Cool. Alright, and now we already solved for IAN in the previous question. So let's look back with how IAN was. 0.895 times 17.2. So just plug it in. 0.895 17.2 multiplied by our degree negative 30, and just divide this by root 3. So now how do you do this? 0.895. Whenever you're multiplying these angles, they just add together, so that becomes 17.2 plus minus 30. Just do that. And then over root 3, do the same thing for IP and IC. Cool. That's part C. 5 marks. Boom. Lastly, we're gonna solve for the complex power produced by the voltage source. Okay, so now there's a formula for this. The formula is 1/2 of the voltage times the current is equal to the complex power. So, and how do you solve for this? Like our voltage, we already solved for that. No, we didn't solve for that. The voltage is given inside of the question. So if you look over here, this is a separate question, but same shit. Voltage over here for A is 35 angle 0. So we just plug that shit back into our equation. 35 angle 0. Cool. That's 1/2. And now what is our current? Our current, so since we're looking at the voltage source, we're going to use the current across the voltage source, which we already solved. Which we already solved right over here. You're going to use this. You're going to use this. Let me solve this real quick. 0.895. I should have solved this beforehand. Divided by 3. Okay, so this is gonna give us 0.516, and then our angle is gonna be 17.2 minus 30. 0.2 minus 30. The hell? Why don't I know how to do this? Okay, yeah, whatever. 17.2 minus 30 is gonna give us like minus 12.8. Okay, cool. That's gonna be our IA. So we just have to use this and plug it into our formula, which is 0.516, my bad. Root, okay, our angle is negative 12.8, but remember, you see this star over here? This is our formula, this is the conjugate. If it's a negative, it becomes positive, positive becomes negative. In this case, we had negative, so it's going to be positive 12.8. Cool. Plug it in. Solve. There you go. You got S, the complex power of S. Now do the same thing with complex power of B, complex power of C. Cool. You, instead of like use voltage at A, voltage at B, and then voltage at C with the corresponding current at A, B, and C. Cool. Done. Boom.